Hey, I'm Brendan from Novo Media. Today, we're going to look at the logic behind an automation pipeline that generates AI media by running a custom Python script. The goal is to build a system that can produce this exact shot, a cinematic close-up of a golden retriever playing in a sunflower field, without you ever opening a web browser. We'll do this by writing a script that communicates directly with Google's Veo 3.1 API to request the video and download the completed MP4 file. To follow along, you'll need Python and the Google GenAI SDK installed, along with an active API key. Moving this process into a script allows us to bypass manual UI clicks. It's the first step toward building a repeatable, programmatically controlled workflow for your creative projects. We'll start with the setup. Open your code editor and import the required Google GenAI libraries. We also need the time module. AI video generation isn't instantaneous, so we need a way to tell our script to pause while the server processes the request. Next, we initialize the GenAI client, which serves as the primary interface between our local code and Google servers. This is where most scripts fail on the first run. For the server to validate your request, the client must pull your API string from the system's environment variables. If that variable is missing or incorrectly named, the handshake fails and the script terminates. Once the client is authenticated, you have a stable connection to Google's cloud computing resources. Now we can define the request. We use the Generate Videos command and specify the exact model version, in this case, Veo 3.1. Within that command, we insert the prompt string describing the golden retriever and the sunflower field in detail. Finally, we add the configuration block. This is where we define the technical parameters of the file, such as a 16:9 aspect ratio and a duration of 8 seconds. This block serves as a precise set of instructions that the API must follow to render the specific media you want. Because high-resolution video rendering takes several minutes, the local script cannot simply move to the next line of code immediately. We solve this by building a while loop that asks the server for a status update at regular intervals. We use time.sleep to pause for 10 seconds between checks. This prevents overwhelming the API and getting throttled. The cycle continues until the server reports the status is done, at which point the loop breaks, making the data accessible. This polling loop is the essential mechanism that keeps the script running while waiting for the cloud render to finish. Once the operation is complete, we write a line of code to extract the specific video file from the API's response payload. The final step is the download command, which instructs your computer to save that extracted file to a local directory. This successfully bridges the gap between a remote server and your local machine. Let's run the completed script in the terminal. You'll notice the terminal pauses. This confirms the polling loop is active and waiting for the server to finish the rendering process. When the loop finishes, the script exits, and the new MP4 file appears in our folder. If we play it back, we can see the result. A new shot of a golden retriever bounding through sunflowers, rendered according to the parameters we set in our code. Now that the pipeline is working, you can experiment by swapping out the prompts or adjusting the duration in the configuration block. Creating your own automation tools doesn't just save time, it provides a repeatable framework for generating high-quality media on demand.